Okay, lesson 27, I can find the percent of a quantity. I can solve problems involving finding the whole when given a part and the percent. This is the same lesson content goal for the next 3 lessons, where we are either going to be given, if we know the whole, and we are asked to to find the part when given the percent, or we might be given the percent and the part, and then asked to find the whole. Okay, or we might be able to find the percent of the given quantity of the whole thing. So we're going to be looking on building and really understanding in this lesson, which of these things am I finding? Am I looking for the part? Am I looking for the whole? So we're going to dive a little deeper into what to look for in order to determine that. So let's get started. Example 1, solve the following 3 problems. Write the words percent, whole, or part under each problem. So right here, and right here, to show what piece you were solving for. So if you notice here, these 3 problems look very similar, but they're asking for 3 different things. So let's try to figure out what kind of key information is going to tell us what we're solving for. I like to draw a picture of something to help me make sense of it. So in this first one, I'm going to demonstrate by showing you a picture. So this one says 60% of 300. Okay, so what that means is, here's the little picture. So 60% of 300 is what we don't know. So I know that the whole thing is 300. I know I'm looking for 60% of that, but I don't know what number 60% of that is. I know it's smaller than 300 because it is just a part. Okay, so in this one, we are looking for the part. Now, how I can set that up to solve for that is another thing I want to dive deeper on in this lesson. So we're always going to start with the percent. So 60% of 100, or 60% is over 100. The percent's always going to have 100 as the denominator. But we want to reduce it down to its simplest form most of the time, if you are able to. So for example, in this problem, I can reduce that to 6 over 10. I can reduce that to 3 over 5, okay, if I want to keep reducing it down. But just to model this right now, I'm going to show you without reducing it, just to keep it really simple. So 60% of, we want to figure out 300. Should I put that here on the numerator or should I put that on the denominator? Well, let's think about this. Whatever the total is always goes on the denominator, because the part is the smaller number, and most of the time the smaller number is the numerator. It's a portion of the total. So if I know the whole, that means I know the denominator. I know it's 300 right there. I do not know what the part is. I don't know the numerator. So I'm going to look for a pattern here, and I actually do see one without even having to reduce. I see 100. If I want to get to 300, I'm multiplying by 3. So if I do that same thing here where the 60 is to find the numerator or the part, I do 60 times 3 and I get 180. So 180 is the part. And again, you always want to assess, is that answer reasonable? Think about this. 60% of 300, that's just over half of 300. And a half of 300 is 150, so 180 is over half of 300. That answer makes sense. If I got a number that was bigger than 300, that can't possibly only be 60% of it, because it's a little more than half. It's going to be a smaller number than 300. So just always assess your answer for reasonableness, because that's a great way to catch if you set the problem up correctly or not. So for this next one, it says 60% of something is 300. So if I know the quantity 60%, Let me set it up here in a picture again. So 60%, it's a little more than half, of some number is 300. That 300 is representing this 60%. So what I'm looking for here is my whole. Okay, I should be getting a number here that's larger than 300. Okay, because it's 300 plus more to get this number, the whole. So when I'm setting that up to solve, once again, I'm thinking about the numerator and the denominator. I'm starting with 60% written as a fraction so that I can find an equivalent fraction. I know 300 is the part, the smaller number, the numerator. I don't know my whole, so I don't know my denominator right now. That's what I need to determine. For this example, I'm going to reduce this down. I probably can find a way to get from 60 to 300, but I'm going to reduce this down. So I know it reduces down. If I divide by 10, I have 6 over 10. But it reduces down even further because these are both even numbers. So I'm going to reduce it down even further to 3 over 5. Okay, now I can look for patterns. Cover this up for a second. So I want to get, let me zoom in. I want to get from 3 to 300. So I know I'm multiplying by 100. And I'm going to do that same thing with my 5 to find an equivalent fraction. I know I need to do the same thing to both numbers. 5 times 100 is 500. Oops. So 60% of 500 equals 300. I can assess this answer for reasonableness because, again, 300 is more than half. 60% is more than half, so 300 is actually more than half of 500. So I know that's a reasonable answer. Now in this last one, it says 60 out of 300 is some percent. So in this one, I know I'm looking for the percent here. There's no percent given to me in this problem. But I know 60, when I hear out of 300, I know the part, I know the whole, but I need to calculate the percent. Now, percent is always, always, always out of a total of 100% because you can't possibly give more than 100%. So now I can look for a pattern. If I want to get from 300 to 100, I know I'm dividing by 3. If I want to get, I need to do the same thing to this side as well. So 60 divided by 3 is 20. So my answer, 20 over 100, written as a percent, is 20%.